When we talk about surveys in archaeology, what do we mean? Unlike in the movies, many archaeological sites and wonders aren't uncovered by sheer chance or by digging randomly in the sand. Most sites are discovered through a systematic process of detecting and documenting evidence of past human activity across landscapes, what we call archaeological survey. Surveying helps archaeologists answer questions like, where were people living? How were they using the land? How dense was their occupation? Or what patterns of artifacts or features show up across space? There are three main types of survey: ground survey, subsurface detection, and aerial reconnaissance. Let's compare them. Ground survey, also known as surface or pedestrian survey, is the oldest and most basic method. It involves people physically walking across a landscape, systematically scanning the ground for artifacts or features visible on the surface. Researchers may walk in transects, or parallel lines, or other systematic paths, depending on terrain visibility, vegetation, and research goals. Factors like distance between walkers, how often one stops to inspect, etc., depends on how easy it is to see artifacts, like color, contrast, vegetation cover, all matter. Ground surveys are non-intrusive. You're not digging yet. You are merely observing, recording, and maybe collecting surface finds. As far as surveys go, ground surveys have a few advantages. They're fairly cheap, and it's good for detecting sites with surface materials or significant features like building foundations, but you could miss buried features or have low visibility because of plants growing over your site, and large areas take a lot of time to survey this way. Now, if you're looking for something buried beneath the surface, many archaeologists use subsurface detection. Similar to ground survey, subsurface detection is non-intrusive or minimally intrusive. Non-intrusive methods are things like metal detectors or geophysical methods like ground-penetrating radar, GPR, magnetometry, and resistivity. All three of those geophysical methods send various signals into the ground and measure how they bounce back, or show differences in physical properties of what's under the ground. With that data, you can generate a map of what's below the surface, like buried wells, houses, or roads. Minimally intrusive methods of subsurface detection are things like probing or shovel test pits, where archaeologists dig small holes to check what's beneath the surface in specific locations, sampling to confirm if anomalous signals correspond to archaeological remains. Some advantages to using subsurface detection are that these methods can detect buried features not visible on the surface. They can help focus later excavation and minimize damage to the site. There are some disadvantages, though. Some tools are expensive, interpretation of data can be tricky, and some methods work better in certain soil types than others. The last type of survey we're going to cover is aerial reconnaissance. This means looking at the land from above to spot signs of sites that might be hard or impossible to see from the ground. By using aerial photography, drones with data recording payloads like cameras or LiDAR, or satellite imagery, archaeologists can look for things like earthworks, such as ditches, banks, walls, or burial mounds, which cast shadows or show up in the terrain. We can also see crop marks, where buried walls or ditches affect plant growth above them. The thinner soil over walls means stunted growth, or more moisture in ditches leads to lusher vegetation. We can also see soil marks, differences in soil color or texture made visible, for example, by plowing or erosion, where buried features have altered the soil. LiDAR, which stands for light detection and ranging, can map the ground surface very precisely. LiDAR can see through vegetation to reveal subtle features under forest canopy. With aerial reconnaissance, archaeologists can cover large areas quickly and reveal features not visible from the ground. It works especially well in forested landscapes. But the cost can be steep, and affordable equipment can have resolution limitations, and also weather and light can interfere. Often, though, archaeologists use a combination of all of these methods. Aerial reconnaissance to identify candidate areas, ground surveys to inspect surface evidence, and subsurface methods to see under the surface. Then test pits or partial excavation to confirm and date things.